Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and as part of our discussion on different types of surfaces in sequence stratigraphy that we are discussing through last few classes. So, today we will also continue this discussion, and today we are going to discuss about another very important surface in sequence stratigraphy, which is called as maximum regressive surface, abbreviated as MRS, maximum regressive surface. So far we have seen those surfaces, we have discussed about those surfaces which form during the phase of base level fall, and there we have discussed about 4 different surfaces like unconformity, correlative conformity, BSFR, RSME. Today in this particular class we are starting with another type of surfaces, another category of surfaces. So, those surfaces which are associated with the phase of base level rise. So, under this particular category we commonly get 3 different types of surfaces which are very important surfaces. So, number 1 is the maximum regressive surface, MRS, maximum regressive surface, which we are going to discuss in this class. The next important surface that also forms during the base level rise is maximum flooding surface, MFS. This we will discuss in the next class. And the third one is the transgressive ravinement surface, TRS, transgressive ravinement surface, which also forms during the base level rise, particularly that, as the name suggests, it forms during transgression. So, in successive classes we will discuss about these 2 types of surfaces which are also associated with the base level rise, and in today's class we are going to discuss about this particular surface, the maximum regressive surface. So, a maximum regressive surface, it commonly marks the change from shoreline regression to subsequent transgression. So, if I refer back to that fundamental base level curve. So, in this curve we already know, if this was the curve, then within this curve the base level, it starts rising up from this point, but during this phase, during this particular phase, the amount of rise of the base level is slower than the rate of sedimentation. So, we commonly get a normal regression, and then we come over here, this part of the base level rise, where the rate of rise is more than the rate of sedimentation, and we get a transgression. So, the maximum regressive surface is the boundary between these 2 particular phases within the base level curve, which demarcates the end of the regression and the start of the transgression. So, before we come to this particular surface, what we are getting here in this part, a normal regression, as already we have seen, this entire phase of the curve is part of a forced regression, and before this forced regression, at the end of the transgression we get another normal regression. So, starting from this normal regression followed by a forced regression followed by another normal regression, this entire phase of regression is finally changing into a phase of transgression across this particular surface. So, this surface is indicating the maximum amount of regression in that particular basin under that particular phase of base level curve. So, maximum regressive surface, it marks the change from shoreline regression to subsequent transgression. So, this is very important surface. So, definitely when it is a regression, normal regression or forced regression, the underlying strata is prograding strata. It is a progradational stratal stacking pattern. So, below the maximum regressive surface we expect coarsening upward progradational strata, whereas above this particular surface what we expect, the stratal stacking pattern is forming under a transgressive phase. So, during that phase the stratal stacking pattern will be retrogradational, will be fining upward. So, this surface marks the changeover. It separates the prograding strata below from the retrograding strata lying above. So, this surface is quite easier to identify in the rock succession. Wherever we get this transition, we can put the boundary, and also this surface is very important in sequence stratigraphy. This change from progradational to the retrogradational stacking pattern, it takes place during the base level rise at the shoreline, when the increasing rate of base level rise start outpacing the sedimentation rate. This also we have discussed earlier as well, when we have tried to understand the role of base level curve with respect to transgression and regression. So, in response to this, as a result of this, the end of regression surface, after this prolonged phase of regression, the end phase of the regression represented by this surface, it forms within an aggrading succession, because during that phase the base level is rising up, producing extra amount of accommodation within the depositional basin. So, this particular surface is sitting on the top of the low stand normal regressive strata, which indicates the start of aggradation and progradation, and is enlapped by the overlying transgressive deposits, which is often called as, in particular part of the marine basin, is called as the healing phase deposit, as it tries to heal up the erosions caused during the forced regressive phase. So, those transgressive deposits in some portion of the marine basins are called as healing phase deposits, as they covered up erosional phases caused under the forced regressive condition. So, when this kind of scenario is appearing, the maximum regressive surface occurring between these underlying progradational strata and the overlying retrogradational strata, and mark this sharp changeover in the stratal stacking pattern. So, this surface is actually the youngest clinoform associated with the shoreline regression. So, in this case, if I think of the overall stratal stacking pattern during the regressive phase, during this normal regressive phase, as we already know, so they will be prograding forward. So, when that progradation is over and then over that retrogradation starts, so there is no erosion involved. So, basically this is the final surface which is forming, which is demarcating the changeover from progradational to retrogradational changeover, progradational stacking pattern to a retrogradational stacking pattern. So, this maximum regressive surface, this is the last clinoform, the youngest clinoform that has formed during the last normal regression, which is nothing but a low stand systems tract. So, this end of regression surface, the maximum regressive surface, represents the youngest clinoform associated with the shoreline regression, and it downlaps the pre-existing sea floor in a basinward direction, and it covers up the preceding regressive clinoforms, as we have seen. So, when the clinoforms are gradually prograding, the last one will cover up the earlier regressive surfaces, earlier regressive clinoforms. So, it is the draping over the preceding regressive clinoforms. So, the underlying low stand normal regressive strata do not terminate against maximum regressive surface. So, maximum regressive surface in most of the cases is a conformable surface, it is not an erosional surface. Against this surface, the underlying low stand strata, the normal regressive strata, they remain almost parallel, they do not terminate against this particular surface. So, in general, the maximum regressive surface is conformable in nature. In some cases, particularly when we get some sort of transition due to this changeover from a regression to transgression, and if there is a drastic change in the energy condition during this transition. For example, say we have a shallow marine setting, and in that shallow marine setting the high energy waves and tidal currents, they are encroaching in. As the water is encroaching in, water level is rising and it is encroaching towards the land. So, high energy waves and tidal currents are also covering up. So, that high energy wave and tidal current can produce some amount of erosion along the boundary, along the base of the transgressive package, and that erosion may lead to removal of some amount of certain portions of the maximum regressive surface. So, in such cases, when it is a transgressive beach where regular intertidal swash and backwash currents are coming in, flood current and ebb currents are coming in, or maybe within a wave dominated condition, regular waves are coming in such cases, maybe the earlier normal regressive phase, which was possibly a coastal sand, maybe a foreshore sand, or maybe a fluvial overbank. So, that may get partially eroded, which means the underlying low stand systems tract LST is partially eroded by this transgressive erosional process. So, in such cases the maximum regressive surface can merge with that erosional surface and it can represent as a truncation surface. Otherwise, maximum regressive surface is conformable. The end of the shoreline regression event, it marks a change in the sedimentation regime, because before that it was a normal regressive condition, after that it is a transgressive condition where the base level is rising at very high pace. So, the balance between the sediment supply and the environmental energy, it is changing drastically across this particular surface. Below the surface there is accumulation of sediments, more accumulation of sediments than the amount of space created, than the amount of sediments reworked, removed from the system. So, they are accumulating in a progradational pattern, whereas above this, when transgression is starting, the entire environmental system is trying to encroach, trying to move towards the land. Definitely that will lead to change in the environmental energy condition, and that change in the environmental energy condition will lead to change in the distribution of different environments, both landward and seaward with respect to the shoreline. So, across this surface we can expect change in the depositional environments in the overlying and underlying units. And when you are talking about the depositional conditions, definitely that will lead to the associated facies types. So, we can expect drastic change in the overlying and underlying facies types across this particular surface. So, the maximum regressive surface may develop as a discrete stratigraphic contact across most part of the sedimentary basin, from marine to the coastal to the fluvial environments, because after the end of the normal regression, as the transgression is starting, it is occurring in the deeper part of the basin, shallower part of the basin, marginal part of the basin, and also covering up the continental part. So, wherever we are getting this effect of transgression, it will always lie on the underlying normal regressive package and we get this surface. So, the maximum regressive surface may be developed, may be traced as a discrete stratigraphic contact across major part of the sedimentary basin, starting from the marine part to the coastal area to the fluvial environments. We can try to understand this using a very simple diagram. We are considering a basin where this is the fluvial part of the basin, then we are reaching to the marginal part, and then we are going into the deeper part, that is the shelf and even the deeper part. So, what is happening over here during the progradation, during the normal regression? The fluvial system is prograding forward, and that progradation of the fluvial system is producing a delta in this area, and that delta is gradually progressing into the shore environment, and that shore environment is gradually progressing into the shelf environment. So, this is the shelf area, this is the shore area, maybe shore face, this is the deltaic part, and this is the fluvial part. So, when this transgression starts after this normal regression, so this phase is the normal regressive phase. At the end of this normal regression, now the transgression starts. So, during this transgression, what will happen? Earlier, the individual units, say for example the self was progressing in this direction. Now, the self sediments will try to onlap over here like this on the shore. So, earlier the contact between shore and self was like this as it was moving in this direction. Now, as the self is onlapping onto the shore, the contact between the shore and the self will be something like this. The shore environment will try to encroach onto the delta. So, this will be the shore part now, and the delta will now vanish, because as the transgression is going on, this delta will be replaced by a new kind of condition on this river system, which we call as the estuary system, and this estuary system will lead to the retrogradation of the fluvial system. So, we are getting a surface across this entire zone, across which we are getting a complete changeover. All these packages, they are onlapping packages, whereas the packages over here in this part, they are all downlapping packages. All downlapping packages, all progressional packages. If I try to make a log anywhere over here, what will get? I will get the shore faces, it is overladen by self. If I make a log somewhere here, it is the shore faces overladen by shore faces again, but it is the shallow shore or the near shore, and this is the distal shore or deeper shore. If I try to make a log somewhere here in this area, what I will get? I will get, initially it was a delta, and that delta is now overladen by an estuary system, or maybe a fluvial system was there initially, and that fluvial system is overladen by an estuary system. So, everywhere across this area, across this entire basin, we will get contrasting sedimentary successions. We get contrasting depositional environment, which results in contrasting depositional systems. So, this changeover from a progressional to onlapping pattern with drastic change in the facies architecture, drastic change in the corresponding depositional systems is characteristic of the maximum regressive surface, which can be traced across almost entire part of the basin. Even we can trace this in the deeper part of the basin with certain difficulties, but even in the deeper part of the basin we can trace this one. So, the preservation potential of this particular surface, this maximum regressive surface which is forming at the end of the regression, is very high, because it is associated with a phase of base level rise, and during that phase sedimentation is going on, not erosions. Sedimentation is broadly going on, resulting in accumulation of thick sediment pile. So, very often we get a very good preservation of the maximum regressive surface. It is highest in the deeper to the shallow marine environments, where it tends to be onlapped by the aggrading transgressive strata. However, the potentiality of its preservation, it may be a bit lower in the marginal part or maybe in the fluvial part, because there this encroaching transgressive sea, it can be associated with some amount of scouring by increasing energy condition, increasing wave energy, tidal energy. So, the shoreline transgression in the coastal area encroaching into the fluvial system in some cases may lead to erosion of the maximum regressive surface. So, in such cases the preservation of the MRS may get hampered, may get disturbed. Otherwise, we can very easily correlate them, very easily trace them across the major part of the basin. Now, if I look from the landward side in terms of this end of regression surface and how the shoreline is moving, the preservation of the maximum regressive surface depends on the balance between the rate of aggradation in the coastal area, basically the transgressive coastal area, which is transgressing into the fluvial system, fluvial environment, which is transgressing over the fluvial system. So, that is the factor 1, how is this balance is changing in terms of rate of aggradation. As the base level is rising, so extra accommodation is created, and the balance with respect to this accommodation, how much this rate of subsequent transgressive wave ravinement erosion, which is trying to remove the sediments, as well as if it is higher, it can remove the earlier substrate. So, that balance will control that what will be the preservation potential, as well as what will be the nature of distribution of this particular surface in the landward side of the shoreline. So, in such cases, the prolonged stage of low stand normal regression may result in the formation of relatively thick topsets of aggrading and prograding coastal to fluvial strata. So, in such kind of condition, if the phase of the low stand systems tract, the low stand normal regression is significantly high, we can get a very thick accumulation of the sediment packages. Those sediment packages covering of the fluvial strata followed by the coastal strata, and they are aggrading gradually, prograding and aggrading, and they try to drape the subaerial unconformity and are preserved from subsequent transgressive wave ravinement erosions, because even if some erosion goes on, the package will be preserved. In such cases, the maximum regressive surface has the potential of being mappable within both marine and the fluvial successions. If this thickness of the low stand normal regressive package is not that high, if it is a thinner package, there are chances that during the transgressive ravinement process, during this erosion during the next phase of transgression, that low stand package may get completely removed, and that erosional surface may get juxtaposed with the subaerial unconformity formed during the forced regressive phase. In such cases, maximum regressive surface cannot be traced, cannot be mapped in the landward side of the shoreline. So, for the preservation of maximum regressive surface in the landward side, what we require is a considerable amount of low stand deposit in terms of fluvial and coastal, maybe a delta, that should have formed with significant thickness during the preceding low stand system tract. Now, if we look into the deep marine part, in deep marine deposits, it is often very difficult to identify the maximum regressive surface because it is a conformable contact, and in the deeper part of the basin, there very rarely we get any drastic changeover in terms of facies transition or facies change. So, within the facies succession, for example, within a submarine fan complex in the deep marine part, it becomes often very difficult to really mark the exact position of the maximum regressive surface, because in such submarine fan complexes, the end of regression event, it occurs during a stage of waning down in the amount of terrigenous sediment supply. As the base level has started rising up, so the maximum wave and tide reworkings are going on in the shallower part, and those processes, since there a delta is forming now, so most of the clastic sediments are getting trapped by those processes in the marginal marine part, in the shallow marine part. And as a result, in the deeper part, the supply of these coarser clastics are relatively rare, relatively low. And as a result of that, in the deeper marine part, these submarine fan complexes, they are kind of monotonous facies architecture, they show a kind of monotonous facies architecture. So, when we do not have much contrast in terms of the facies change, it becomes very difficult for us to demarcate the actual position of the maximum regressive surface in the deeper part of the basin. So, in such cases, no physical criteria can be used, whether you are looking at the outcrop section or whether you are looking at the core sections or whether you are looking at the well log sections. In the continental slopes, the maximum regressive surface is represented by the youngest prograding clinoform, which may be onlapped by the overlying transgressive deposits, commonly we call them as the healing phase deposits. So, if I look at the slope area in the marine basin, where we have a relatively higher slope, higher gradient, there at the end of the force regression, as the base level starts rising during the low stand phase, sediment starts accumulating over there in the form of a prograding delta. So, that prograding delta, where we are getting a downlapping package, a prograding package, gets changed into a transgressive package as the transgression starts after the low stand. Now, how this transgressive package is represented there? It is represented by backstepping sediment gravity flow deposits or gravity flow deposits. So, this surface, the maximum regressive surface, is represented by the youngest prograding clinoform on which onlapping packages are developed along the slope. So, that changeover in the clinoform arrangement pattern, stratal stacking pattern, can help us to identify the maximum regressive surface in the continental slope area. But if we look into the basinal part, deep basinal part, ocean floor, there it is very difficult. When we look into the shallow marine system, the maximum regressive surface is relatively easy to recognize at the top of the coarsening upward prograding successions, as I have shown you in the previous diagram. So, there very easily we can identify from the stratal stacking pattern and also through the contrasting facies types which are occurring across that particular surface. Now, depending on the rate of subsequent transgression and also depending on the location within the basin where this is happening, the maximum regressive surface commonly is associated with a lithological contrast in terms of sand shell ratio. The underlying part is more sand dominated, which is a part of the progradational package, and the overlying part, overlying unit is more shell dominated with respect to the underlying package. However, it may not be true across the entire basin, or even within the shallower part of the basin, it may not be true always, but it can be one guiding clue to identify or demarcate the maximum regressive surface. So, maximum regressive surface, it commonly corresponds to a sand by shell contact, sand shell ratio, a changing sand shell ratio, suggesting a rapid transgression or an abrupt cutoff of sediment supply as the transgression has initiated. So, earlier the floor was here where the sediments were supplied under low stand condition. Now, the sea level is rising and it is transgressing. So, definitely in the marginal part, the supply of sediment is obstructed. Sediments are trapped over there, and in the deeper part, relatively deeper part, maybe in the shelf area, now we are getting supply of mud only. So, suddenly across this surface we are getting a drastic changeover in terms of sand is to shell within the resultant facies types. So, under this kind of conditions, the sediments are trapped within the retrograding shoreline systems at the onset of transgression, which leads to sediment starvation in the offshore area or in the shelf area, and hence we get an abrupt facies change at the maximum regressive surface. In such cases, it becomes quite easier for us to identify or demarcate the maximum regressive surface within the sedimentary succession. So, the MRS, maximum regressive surface, can be traced also in the marginal part of the basin. So, in the marginal part of the basin, the maximum regressive surface can be traced at the base of the estuary facies, because estuary will form during the transgression, and that can also be traced at the contact between the river systems, which goes on changing in its form from a braided river to a meandering river system. Say for example, if this is the contact, the last surface during the low stand systems tract, and during that time in the lower part we are getting mostly the channels, amalgamated channels, which commonly indicate a braided river system. This is the seaward side from where the encroachment is starting. So, this surface is the maximum regressive surface in the fluvial system, very close to the shoreline, maybe this is the shoreline. So, the shoreline is here perpendicular to the screen, and from here that sea level is started rising. So, as the sea is encroaching into this, what we will get over here, the boundary will be coming over here, and this portion is becoming an estuary. So, within an estuary again we will get a channel, but this channel is now either it is a part of an central estuary, kind of a lagoon if it is a wave dominated estuary, or it can be tidal channels very frequently affected by tidal currents. So, we get tidal channels. So, at this initial part the tidal channel will be here. During the next phase of the transgression, tidal channel will be stepping back over here, and in that way for each and every phase of transgression we will get this kind of backstepping of the channel system. So, in this part we are getting the estuary system. So, the contact is straightway a braided river system overlain by estuary system, where we are getting this kind of backstepping effect. So, the backstepping effect may be in terms of backstepping of tidally dominated channel system, channel bars or channel fill sediments if it is a tide dominated estuary, or it can be the backstepping of the bayhead delta system, which is lying behind the central lagoonal part or central basinal part of a wave dominated estuary. So, in either of these cases, across this surface we get a very contrasting facies architecture and very contrasting stratal stacking pattern. And when this estuary is forming over here, definitely the base level is quite high. So, the energy system in this part will be significantly low, and the river system that will form over here will be a simple low amalgamating meandering channels. So, in this part also what we get, a braided channel is overlain by a meandering channel system across this particular surface. So, in the marginal marine part to continental part, especially where we are getting this effect of base level change within the fluvial system, there also we can demarcate this maximum regressive surface quite effectively in terms of this sudden changeover in the stratal stacking pattern and sudden changeover in terms of the depositional system. So, the maximum regressive surface can be traced at the base of central estuary facies and at the contact between braided and meandering systems in the inland side, inland with respect to the shoreline. The extension of the maximum regressive surface into the fluvial part of the basin is sometime bit difficult to pinpoint, because the changeover in terms of river profile cannot be that drastic, it can be very gradual. But when we look at a regional scale, we can very easily understand that this changeover corresponds with an abrupt decrease in the fluvial energy. As we are moving in over here in this particular zone, the energy condition of the fluvial system is decreasing because the base level is rising. If we think of in terms of the fluvial graded profile, during the low stand condition, the fluvial graded profile was like this, just for example. Base level was here and the fluvial graded profile was like this. This is the fluvial graded profile. So, due to this profile, we are getting braided river system was forming over here, which was supplying the sediments and forming a delta in this part. Now, during this transgressive phase, the base level has risen over here and the fluvial profile, equilibrium profile, it is adjusting to this level. So, definitely the slope has changed drastically, which will lead to decrease in the energy condition. Decrease in energy of this river flow system, which will change the river flow pattern into a meandering river system. So, we will get an estuary over here followed by a meandering river in the landward side. So, this changeover, which may be very gradual from a braided river to a meandering river, and that may be very difficult to pinpoint on, say for example, in outcrop scale. But when we go in terms of regional scale view, it can correspond, it can be very easily identified in terms of change in the fluvial energy system as it is gradually decreasing upward. And that changeover in the fluvial energy system will be represented in terms of the facies architecture, fluvial facies architecture. So, in the lower part, when we are looking into the braided channel fill, there we will get dominantly amalgamated channel fill systems. Broadly, the braided channel fill systems which are amalgamated very frequently, whereas the overlying part which we are interpreting as meandering channel, there the amalgamation of the channels will not that dominant, rather the channels or channel fill sediments will be separated by thick overbank deposits, which is one of the key criteria, primary criteria to distinguish between braided river system and meandering river system. We will discuss about this particular aspect later on also when we will discuss about the fluvial sequence stratigraphy. There we will discuss about this particular topic, this particular aspect in more detail. So, the maximum regressive surface, which is a very important surface as we can see from this discussion in this particular lecture. This surface has relatively low diachronity because it is associated with the transgression, it is associated with the end of the regression. Since the sedimentation is going on everywhere across the basin along the deep section, so we expect very low diachronity along the deep section. But the diachronity rate may substantially increase along the strike, as we have seen in case of other surfaces as well, because along the strike the conditions may vary in terms of the accommodation creation, in terms of the sediment supply, in terms of the river inflow. So, those variabilities, those factors in the rate of subsidence, rate of sedimentation, rate of accommodation creation, that can lead to the encroachment or formation of the maximum regressive surface at different times in different parts of the basin when we particularly move along the strike. So, this surface may show relatively higher diachronity when we try to trace them along the strike. So, finally, if I want to conclude over here, in this particular lecture we discussed about the maximum regressive surface, which is a very important surface in sequence stratigraphy, as it separates out the total regressive package from the transgressive package during one phase of base level change, one phase of base level fluctuation. Earlier we have seen during our class on types of sequence, there we have seen that maximum regressive surface can be used as a very important sequence boundary. So, this particular surface can act as a sequence boundary as well as it acts as a boundary between the system tracts, separating the low stand system tract below and the transgressive system tract lying above. We have seen that in this particular lecture we have tried to understand that how we can identify the maximum regressive surface across the basin, starting from the deep basinal part to the slope area, to the self and shallow marine area, to the marginal marine part, where an estuary may replace a delta system or an estuary may replace a fluvial system, and finally into the fluvial part in the landward side, where a braided fluvial system may get changed into a meandering fluvial system. So, altogether this is a very important surface. These are some of the references for further reading. Thank you everyone.